Welcome to Fun with Physics. I am your host, Kyle Danes. Today, I will walk you through the exciting world of physics and the brilliant mind of Sir Isaac Newton. Our first lesson will be on Newton's first law, also known as the Law of Inertia. To give you a visual aid of the man we are here to speak about, allow us to give you a totally original representation of Sir Isaac Newton. This man right here was credited with the discovery of the Law of Inertia. The law of inertia states that an object at rest will stay at rest, and an object in constant motion will stay in constant motion unless acted upon by an external unbalanced force. This is because objects with mass have inertia, the property of all matter which prevents its motion. To prove the law of inertia, we can consider the headrest on the seat of a car. As force is applied to the car to accelerate, the inertia of your massive head causes it to want to stay where it was, while the rest of your body and car move forward. The headrest on your seat prevents you from getting whiplash. The whiplash a person experiences when their car accelerates can be explained by an FBD of both the person's head and body. First off, both the body and the head experience a force of gravity downward, which is then counteracted by the normal force. Thus, both the person's body and their head have a vertical net force of 0. However, the car exerts a force forward on the body, but not on the head. Thus, the head experiences whiplash as inertia attempts to keep the head stationary, while the force exerted on the body by the car causes the body to accelerate forward. Also, to prove the law of inertia, there is the good old-fashioned tablecloth trick, which will be demonstrated here by our artistic abilities. In case you missed that, allow us to put it into slow motion for you. Here, we can see that the force applied by the friction between the tablecloth and the plates and glasses is not enough to overcome the inertia of the objects, and thus the objects maintain no motion. The free body diagram of both the plates and the glasses on the table can be shown with a free body diagram that will demonstrate no horizontal forces, because the tablecloth applies negligible force on them. The force of gravity is countered by the normal force, which gives a vertical net force of 0, and thus an overall net force of 0. The objects do not move. To finish our lesson, we have one final, although unrealistic example of how inertia works. In this scenario, we are assuming a weightless environment. While riding his unicycle, both Kyle and the unicycle are moving at a constant motion and have mass. Thus, both the unicycle and Kyle are experiencing inertia. Interestingly, when the unicycle's motion is stopped by the curb, Kyle, who has no forces acting on him, and thus a net force of 0, remains in constant motion. Here we can see the free body diagram for Kyle in a weightless environment, with no external forces being applied. Due to the fact that there are no external forces, Kyle can be represented as a square. In conclusion, inertia is a phenomenon which keeps objects at a constant motion. When experiencing a net force of 0, objects in motion will stay at motion, and objects at rest will stay at rest. This has been Fun with Physics. Until next time, I'm your host, Kyle Danes, with your visual artist, Nathan Pierce. We'd like you to have a wonderfully enlightened day.